In this video I want to show you what I use to edit Scheme code and write projects in Scheme, or more specifically Chicken Scheme. And I'll walk you through my configuration, and I'll show you some stuff, and then I'll show you a quick example project to show you how it all comes together, kind of. Alright, so first off I want to mention Geyser, of course, if you're looking for what kind of programming environment you can use to edit Scheme code. You've run into Geyser, and I've used Geyser for quite a bit, and I think it's fine, it's okay, it does what it's supposed to do, but I found it kind of annoying. I mean, I've used it even in the video when I talked about the static site generator, or my static site generator. And I mean, you can see there, and it's fine, but like one thing that really annoyed the hell out of me is the evaluation results buffer. So you don't get your evaluation results in like a REPL or in the REPL, but rather in a separate buffer, and which kind of sounds cool, and I mean it kind of is, but it's just really annoying when you do something like printf debugging, where you just have a bunch of print statements in your code and you want to see what your code does, and Geyser doesn't show you the print statements, because whenever you evaluate anything you only get like the one result, but not all the other output. So anyway, I tried to get around that by writing to like a buffer or a file and then reading the file, but it's just like really annoying. So, okay, so let's get into it. So I want to show you my config here without Geyser. First of all, this is just so you're not confused, so this my installed package is just a function where it looks whether the package is installed and then installs it if it's not. Oh, and this is obviously Emacs, so this is my Emacs config for Scheme. Alright, so the first thing I use, and I mean this is not a package per se, but just a Emacs list file, is Scheme here. And what Scheme here does is, okay, no, let me start off differently. So what I use, because I don't use Geyser, is I use the CMU Scheme mode that's built into Emacs, so a mode for Scheme. And so you have a REPL and all that stuff built into Emacs, a Scheme REPL, and this is fine, but what's really a pretty big limitation is you only have like one Scheme REPL. So whenever you're working on multiple projects, I mean it doesn't work, because you have like one shared REPL, and I mean that's nonsense, obviously. And because I use Emacs server, I only have like one Emacs instance. So yeah, that's a problem. And Scheme here solves this by providing a Scheme REPL and a Scheme process for each project. So I don't know how, I think it's per directory. So yeah, if you have two different directories and you have Scheme code inside them and you start a REPL, it just starts two REPLs. So yeah, that's pretty good. And I mean, I have this big comment block here because I've patched this Emacs list file like with these two lines, and I mean I'll show you later on what these actually do. It's kind of a hack. I don't know why this is necessary, but yeah, I'll show you when I show you the example project. Alright, so next up is chicken.el. Again, this is not really a package, an Emacs package, but rather just an Emacs list file. And I mean, I think Scheme here is like 200 lines, and Chicken is also 200, or something about that. Something around about that. And chicken.el just provides like a bunch of stuff. For example, it provides integration with Chicken documentation, so you can do like you have a binding to look up documentation on a certain function and stuff like that. It also provides like I think something for syntax highlighting, I think, and stuff like that. So it's just like Chicken specific stuff. I guess. Next up is Scheme Complete. So this is an actual package, and this provides a auto completion framework for Scheme. And here I just integrated with Company, which I normally use, or which I use for my auto completion stuff, and yeah, it works pretty good. So yeah, but again, I'll show you. Next up is Dumb Jump. So this is a package for jumping to code definitions. So you have like a function, and you want to see, okay, where is this function defined? You can use dumb jump to jump to it. And dumb jump it's called dumb jump because it's actually a bit quote unquote dumb, because what it does is it just uses grep, or I think some what's it called, rip grep or something like that. Yeah, so this is just setup. So this is not necessary. I use this debug. I set this debug flag because I wanted to jump to like function definitions in like chicken in chicken extensions. So, and I couldn't figure out why it didn't work, and I've also patched this file and added my chicken install directory. So in this cache directory there are all the extensions that I've installed through chicken install, and their scheme code actually, so not just the compiled binary, or the compiled object file, or rather what's it called, library file, but all the actual scheme code, so you can jump to definition in the library code. So that's pretty cool. But again, I'll show you. And the final three packages I have here are Power Edit, Evil Clever Parents, and Highlight Parentheses. So Power Edit is like a classic. I mean, whenever you're working with Lisp code, you want Power Edit, and I don't use this enough to be honest. So there are a lot of bindings for Power Edit which are great. Evil Clever Parents is like an kind of addition to Power Edit. So it just provides some evil bindings, because I'm using, as you may have noticed, I'm using evil mode. It just provides some VI like bindings for Power Edit. And Highlight Parentheses is also pretty nice, but I'll show you in a second. So, and then I add these as like hooks to scheme mode. Alright, so that's all good, but let's actually look at a project. So let's make this a bit bigger. Alright, so what I have here is a pretty simple web server project. So okay, we import all the stuff. Whoops. We define some routing function and we start a server thread. Alright, pretty simple. So okay, but what do you need to do to actually run this scheme code? So what I first do is I start a REPL, and it's done with CX. So, and notice all these automatic imports, just because of my CSI configuration. I think it's in the home directory .csirc or something like that. Okay, but that's a topic for another time. So we import all this stuff automatically. Alright, but this is really where it starts. So we can now type something into this and get back the result. I don't know why it jumps down there. That's kind of weird. Yeah. Okay, or we can do something like this. Okay, whatever. And wait, let me make this a bit bigger also. Okay, so yeah, great. So now we can start evaluating this, and notice, this is just what I said a second ago. Notice these red parentheses here. So this is because of the what's it called, highlight parentheses package. So I mean, and you might say, well, okay, great, they are red, whatever, and now they are black, okay. But what's really cool is when you're inside some nested code. So for example here, you get like, okay, the next parentheses are like bright red, then they're like the color kind of fades. So I think it's, and you can configure how like the colors and stuff like that, but I haven't because why? Why would I? I think this is fine. And it's kind of nice to see that like which parentheses match. So you can see pretty easily that this and this parentheses match. These parentheses match just based on color, or this and this. So it's kind of subtle. I don't know how much this actually does, like in like real life programming day-to-day activities, but I think it's nice. Yeah, I like it. Okay, but back to evaluating scheme code. So now we can do this with XE. So this evaluates something. So, or we can also, like, for example, this, and XE evaluates this to A. It's even bigger. Or we can do CC, and this is normally how I do it, especially for nested code. So we can do CC. So this evaluates the outermost, how's it called, the function, definition, whatever. Yeah. Okay. So let's define this ex route function or root function. And we can be so okay. Let me think. So with XE, it evaluates the next thing that's right before the cursor. So we can evaluate this with XE. But if we do, if we have this and evaluate this, it doesn't care about the A symbol. It only cares about the quote B. And so if we go here and we evaluate, and we are basically, for example, here in this code, and we do XE, it evaluates the thing that's right before the cursor. So this would be this equal function. And we get back, okay, this is a procedure and it's equal and takes 2 arguments, okay, whatever. But we don't care about that. We actually want to evaluate the define here. So we could jump to the end of this define and do XE, and that's kind of really annoying. Or we could just use CC and define the outermost definition. Oh, what's it called? I think there's a term for the defun. Is that it? I don't know. Okay, so we've now defined this X route function. If we call this now, we get back to procedure. Takes 1 argument. Okay. Great. And we can do the same here with the X start server thread. And this is also defined, and now we can define this S thread. Yeah, so let's define that. Alright. And I want to, let me go back to my configuration. I want to show you this in action right here. So, why this is necessary, and why I have patched this in with, and marked it with this big comment. Let's go here and let's start a shell and curl localhost. I think it's 7000. Yeah. So we get back hello world because we send response hello world here, and we start the server on thread 7000. Okay, so that's cool and all. And now we do some, I don't know, we do some changes, and now we want to evaluate our function to reflect those changes in our running scheme process. And now what CC, the binding control C with which I've used to evaluate the outermost form, does is normally it jumps to the end of the definition, which is normally right here, so below the actual definition. And this is really stupid. I found this to cause like a problem with chicken threads. So if we call XE here, it evaluates fine, and it's all fine and good. But if we now call, and I hope this doesn't work now, as I've found it to not. Maybe it works now, and this is just all a big joke. But yeah, so if we now curl our web server, it freezes. and I don't know how, like, I don't know what's the correlation here, like, I don't know. So, and the fix, quote unquote, I found is to call the thread. So we've defined this thread here, and if we call it now, it wakes it up, and now it works fine again. So I mean, this is idiotic. And the fix I found is to not, you can't be a line under, so you can't have this new line here, but you must be on the same line. And if we now call xe, it works fine, as you'll see. So yeah, this works fine. So, and this is what this patch is. So it goes to the previous line, and it moves then to the end of the line. So when cc normally goes to end of defun, so it's a defun. So we go to end of defun, and this is like here. So we need to move a line up and go to the end of the line, and then where we want to be to not cause this thread to freeze. So yeah, this is pretty stupid, but this fixes it. So yeah. Okay, what else can I show you? Let me think. So now you can make changes to this called cc. Oops, and everything works fine. Yeah, pretty cool. Oh, I've noticed my screen key thing stopped working, but whatever. Oh, maybe we can call it again. Screen key. Oh yeah. Okay, great. Yeah, let's jump to definition. So we have this x start server thread. So if we can now call meta dot, it takes a second, but for whatever reason, and now it jumps us to its definition. So this is pretty cool. We can do the same with xroute. All right. And now I want to show you this fix down here. So because I've added this cache path to the search parameters or to the grep parameters. So normally it just searches the project directory, but now it also searches this cache directory. And what we can do now is, for example, jump to send response. So if you do that, we jump to send response in the spiffy scheme code. So yeah, this is pretty cool. So now we can look at the code, see what it does. See, that's pretty complicated. Okay, and we can jump back with meta comma, and we're back to where we were. Or we can do the same with URL path. And this is yeah, and then it actually asks us which, if it finds multiple definitions, it asks you which one you want to jump to. So that's also very useful. Oh yeah, autocomplete also, as I said, works fine. So if I start typing, it just shows me which options for autocompletion. So yeah, that also works. And I don't know what else can I show you. Oh yeah, I can show you, for example, this. Oops. Apropos. Okay, let's import all this stuff again. And now we can have now there's a binding, I think CA, and if we call that on a function, it shows you which I don't know which extension, where this function is found, what type it is, and what parameter it takes, which parameter it takes. So yeah, and this is I don't know, it's not exactly, but it shows you which possible functions there are. And there's also CD, which shows you the actual documentation for the function. So this is really useful, and this is in this chicken.el file. So this comes from here. This is really useful. Yeah, so you can see now you can read all the stuff and be like, oh great. So one problem I found with this is if there's multiple functions with the same name, it doesn't work. So okay, so with this it works, but with let's do a string, I think it's this I don't think doesn't work. Yeah, I think doesn't work because there are multiple functions with this name. So I haven't found a solution for that. Yeah, I don't know. if you know how to solve this, leave a comment, I guess. Yeah, but still, this is really useful, obviously. So, or we can do this, and yeah, so really, really useful. And I don't use this enough, to be honest. I should use it more. Yeah. Oh yeah. So another thing I want to show you is, of course, PowerEdit and this evil clever parents package. So these two. So PowerEdit allows you to, for example, do this. So we have a function, hello, I don't know, and now we have like a outer function. Okay. So for example, this, and now we have some, I don't know, string here, whatever. Like whatever, it doesn't really matter. And what you can do now with PowerEdit is you can do this, for example. So you're in here and you realize, oh no, this string should have been part of this, like should be an argument to this hello function. So what you can do now is you can do control and arrow right to include it in this form, or you can do arrow left to exclude it. So really useful. And what evil clever parents does, it gives you VI bindings for this. So you can do, for example, a right angle bracket or left angle bracket. So again, really useful. And sometimes this is kind of confusing, because if I do right angle bracket now, it includes this form. If I do it again, it includes all of this, and yeah, so it can get a bit confusing with complicated code. But again, this is like really, really annoying. So especially for something like an AND, I mean, like you can just include stuff and exclude stuff, and it's great. Or for a cont or define, or like anything, like it's really great. And this is because like obviously this this parentheses syntax makes it so easy to do something like that. And again, PowerEdit has like a ton of stuff. So something I also use pretty often actually is like meta R, and I don't know if there's an evil clever parents binding for this. I haven't looked it up. So if you do meta R, it replaces the outer form with, well, what you call meta R on. So this is also really useful, especially more complicated code. And you can do this not just with like function, like parentheses surrounded code, but also with like strings. So yeah, I don't know, this is really useful. I use this all the time. So what else is there? For example, meta S to I think it splices. I don't know what the actual definition is, but it just splices the code into its surroundings, so it removes these outer parentheses in this example here. Yeah, let me think. Yeah, so this is also pretty useful. Okay, what else is there that's important? I don't know. I think that's pretty much most of it. Most of what I use. So CC is the main thing I want to re-emphasize. That's the main thing I use. Oh yeah, evil clever parents also has like some limitations on what you can do. So for example, if I call dd to delete this line, so normally dd deletes a line, and if I call it here, it deletes the line, but it doesn't delete the parentheses. So the closing parentheses, because that obviously would break the balance. And this is I think that's actually a PowerEdit thing, but evil clever parents just makes it so it works with VI bindings or with evil mode. Yeah, I don't know. I hope I haven't missed anything, but I think that's most of what's important to start editing scheme code in Emacs. And I would recommend Emacs to anyone. To anyone period, but also to anyone editing scheme code or working on scheme projects, because it's great, and I think this integration is also great. I haven't had any problems, well, any big problems I couldn't solve on my own with the setup, because it's kind of hacked together. I mean, fucking hell, these are like separate Emacs list files, and we can look at them. Scheme here, for example, and you can see it's just Emacs Lisp, and it's like 200 lines, so you can actually hack on this, as I have done here, and you can look at this, and yeah, here's my fix. So yeah, that's pretty cool. And here's the chicken.el file, and you can find these on the internet. So yeah, don't worry about it. That I'm not showing you, or that I'm not providing these in like a Git repo. Yeah, and so for example, here's the scheme project name, which by default starts. So you could edit this, and yeah, I don't know. It has like tons of stuff. It has a trace thing. Yeah, I've used this once or multiple times in my in the static site generator when I was working on that. Yeah, it has this chicken doc thing, which I've shown, or this apropos thing. Yeah. Oh yeah, you can also load, because evaluating all the forms in like a big file is kind of annoying. You can also load the entire file with like CL. So Control C, Control L, loads the entire file, and yeah, it obviously tells us, well, this doesn't work. Port 7000 is already bound. And if we go back to this this shell and call this call again, it again freezes, and we have to wake up this stat. So this is kind of annoying, but I mean, often we load a file, and if we were to delete this, it would actually work, because there's no new line at the end. So yeah, I hope this was useful somehow, even though it maybe was a bit unstructured. But yeah, I hope this gave you some inspiration for your own scheme editing, hack together IDE environment. Yeah, I don't know what else to say, so I guess that's it, and have a nice day.